Hello everyone. Today we will predict the board game Greek review data from Calgal. So it has around 15 million rating data from Board Game Geek review website. So first we will import the data for so we can see we have around 15 million data, 15 million row, and it has around review of around 1900 320 games. Next, to get a good idea about our analysis, we have to get rid of all those columns that has no values. For example, no comments. This one NaN. So we have to get rid of this first. Then we get rid of, using this command, we will get rid of this, and now we have around 2.9 million data. So next we will shuffle. So to get a good homogeneous mix of the data, we will shuffle the data, and if we plot the data and if we see within this graph that this is the top 15 most reviewed board games, and on an average the rating is between 6 to 9. Next we will split the data set in, it will be 60% will be training data set, 20% will be development data set, and the rest will be test data set. Next is an important process. We will do data pre-processing. We will lowercase the data, we will remove the stop words, we will remove the punctuation, for example HTTP or add or these symbols, then we will tokenize the data. So these are the stop words we will get from this was the stop words we have. Next, with this one we will remove the punctuations, then we load the data and we get around, like, this data is around this 50 words are the common words we have. Next we will do knife-based classifier for our analysis. So there are like multiple knife-based classifiers. We will use multinomial knife-base, complement knife-base, and Bernoulli knife-base. Multinomial knife-base is a very effective one for text classification. We will check the other two as well. So also we will check the database for different alpha values for multinomial. For example, we had check alpha 1, alpha 2, alpha 3 for 0.1, 0.01, and 0.001. Then for complement knife-based model, we also tried different alpha values, and the Bernoulli knife-based model, we didn't use any alpha values, then we get this, and we'll get an accuracy of 2.83%. Next we have the best model with the highest accuracy is around 0.01, and that's around 30%, and we'll check the confusion rate. So you'll see around 7 by 7 rating. This rating is the most confusion one. This point, other points are looks good. As we saw on the upward that we had most common rating is between 6, 7, 8. So we had a higher confusion matrix for those data. Next we will try support vector machine. Support vector machine takes a little time to do all the analysis. So what we are going to do is we will take 10,000 train data and 2,000 development data to do the support vector machine, and will have an accuracy of 29.5%. So it also has a, you can see that this confusion matrix here. So we have the base model with multinomial base with an alpha equals to 0.01. So within the test data, we'll check the accuracy is around 30%, but this is just we can try more different method for getting a more accurate results.